This is an ordinary stick. But with the help of immersive technology, we can transform how it appears, without changing its physical mass. By removing parts of the stick using diminished reality and adding new visual elements through augmented reality, we create what we call a mediated reality stick, an object that looks different but remains physically unchanged. Our research explores how these visual transformations, like stretching a stick or making part of it disappear, affect how people perceive its weight and the position of its center of gravity. In the first condition, the stretched stick, we used a real stick measuring 60 centimeters. Through augmented reality, we altered its appearance to look shorter, 20 or 40 centimeters or longer, 80 or even 100 centimeters. The physical stick never changed, only its visual length did. In the second condition, the cutout stick, we again used the same 60 centimeter stick. But this time, diminished reality made the center appear visually missing by 10, 20, 30, or 40 centimeters, creating the illusion of a gap. Participants swung the stick in time with a metronome set to 100 beats per minute. This rhythmic motion was carefully controlled to ensure consistency across trials. Despite the visual break, the stick remained physically whole. Participants swung it just as before, under the same controlled conditions. To measure perception, we used the magnitude estimation method. Participants lifted the stick and rated how heavy it felt. They also indicated where they believed the center of gravity was by moving a red dot along the stick. Here's what we found. In the stretched stick condition, the longer the stick appeared, the lighter it felt. However, for the perceived cog, we noticed that the median values tended to shift away from the hand as the visual length increased. In the cutout stick condition, the visual gap had little to no effect on perceived weight. Participants seemed to treat the stick as a continuous object, even when part of it was visually missing. The perceived center of gravity remained stable. According to the findings of dynamic touch research, we calculated the moment of inertia based on participants' reported center of gravity and found a strong correlation with their perceived weight. For a deeper dive into this analysis, please refer to our paper. In summary, our study shows that visual manipulation in mediated reality can significantly alter how we perceive weight,